progression sheet to help us solve some problems and whatnot. So grab your sheet real quick. And like I said, I just want to place this on there. This is stuff you probably know, but it doesn't hurt to have a little bit of extra info there just to kind of help get you through. And what I normally call this one is isosceles triangle info. Okay. Just usually just call it isosceles triangle info. And the way that I would put it, or the way that I would write something out for this, is if the two sides are the same, then the two base angles are the same. That's the kind of stuff that we're going to see in this class. We're going to be given that you've got congruent sides, and then you'll have to do something about finding the angle measure. Okay. So you'll be using that kind of an image a lot. And it works the same way going in reverse, going with the converse. So if you have the two base angles the same, then you have the two sides that are the same. Okay. It works going both ways. Okay. It works going both ways or going both ways? Yes. Going both ways. Alright. And then the other thing that I usually put on here, if you have the space still, is the idea of, if I say triangle ABC is isosceles, and then I would label it A, B, C, where B is the vertex angle. Okay. That way you remember what letter goes where. All right. The easiest thing to remember is whenever they're talking about an isosceles triangle, the first and the last letters are always the angles that are the same, and the middle letter is always the vertex angle. Okay. That all. If you remember that, you're gonna be just fine. Okay. Again, it's not anything overly crazy. I know yesterday on that sheet we had that proof that started out where it gave you ABC was isosceles. You could have used that same definition of isosceles. You could have got the sides being congruent, but I find that if we stick with the algebra stuff with these, it's a little bit cleaner. Okay. Not terrible, I hope. Well, I mean, I should say, I hope it's not terrible. I hope it is terrible. So like I said, the stuff that we'll be able to do then is, if I say that this is 43, what are you going to do to figure out the missing angle? Correct. So how many degrees again are in a triangle? 180. Does that ever change? So we know that 43 is that vertex angle. Just back it out. When you back that out, you get 137. Okay. Remember, whenever you have that, that means when you have these congruent sides, it means you have congruent angles. Since both those angles have to measure the same, and they have to add 137, you just divide that by 2. You get what, 68.5, I believe. And is it okay to get a decimal value for a degree? Absolutely. Okay. Absolutely. It's not a big deal at all. I think the worst thing you're going to get are halvesies. I don't think anything else on that. You know, it's really straightforward. Okay. Not bad. I hope not. Okay. The other thing that happens then, or actually, the other thing that happens with this is we can obviously work with side lengths. So if I know that this side is, I don't know, 8, and this side is 2x minus 3, what do you do to find x? Exactly. So you would just set them equal to each other. Hey, welcome back to Algebra with Geometry again. You know, it's the reprieve of a day or so without the craziness of the proof. So obviously, again, you just add the 3 and divide by 2. just wanted to show you examples that it's okay that you get decimals. You're not doing anything wrong, all right? It's not a big deal, okay? Bless you. Not terrible. The other one was a triangle we actually worked with last Thursday when we were doing the that little computer project thing. Remember how we had the one that said angle, angle, angle? And we couldn't get them, the two of them to be congruent always because you can get different sizes of them? Well, the reason that was happening is because all three of these angles were the same, okay? If all three angles are the same in a triangle, what do each one of those angles have to equal? 60. Very good. So you just take the 180 and cut it, divide it by 3, so you get 60 all the way around. Now, if you follow the rules of isosceles, if you've got two base angles that are the same, what do you know about the sides across from them? They also have to be the same, don't they? But what so happens here is that if these two are the same, and then if I look at those two, well, this one also has to be the same. This is the idea of what's called an equilateral triangle. Okay. The equilateral triangle is even easier. It's got all three sides the same, and all three angles are always equal 60. Always. There is no vertex angle for these, it's just there. Okay. It is really straightforward. So there's no vertex angle. All three sides are the same, and all three angles are the same. Okay. Most people don't really worry about putting all this info on a square for a progression sheet just to have it, but it doesn't hurt any just because it's something that you'll have a tendency to overlook from time to time. So if you'd like, in one of your other squares, it doesn't hurt to put it on here. So I'd say equilateral triangle info. And this maybe just do an if three sides the same, then you got the three angles the same, and then just do the converse. Oops. Okay. And all angles equal 60 degrees. Okay. This triangle, equilateral triangle, is actually one of the basis of trigonometry. We use this triangle to show how right triangle stuff is going to work. We use this triangle to show how to get Pythagorean theorem to work. We use this triangle to show how what's called the unit circle works. It's kind of a big deal, to be honest with you. It's kind of a big deal. With this one, second semester, somewhere around, I think it's like the second chapter we do, after we get through some of the similarity stuff. So again, I would just make sure you have this. And like I said, this is not going to be that difficult whatsoever. Okay. Now, what all this stuff's going to let us be able to do, it's going to be able to get us into algebra problems, figuring out what sides equal what sides, what angles equal what angles. But it's also going to let us draw and do bigger pictures and follow through. Let's see if I can find the picture here. Something like this. And I wanted to jump right into something that looked weird. Now, that looks kind of weird. There's a whole lot going on. But as you'll start to see as we do most of these types of problems, there's always going to be a really, really, really easy place to start. Okay? If I look at this picture, there's how many different triangles there? There's three of them, right? The triangle on the left is a right triangle. The triangle in the middle is what kind of a triangle? It's isosceles. And what's the triangle on the right? Equilateral. Are we okay with that? Everybody see how the tick marks work and you got that right angle box? Okay? So if I start looking through this and start piecing it together, I know that this is 60. This is 60. That's 60. This is 90, good. Okay. And that's 90. Now, what do those three have to add up to equal? 180. Well, how much is left for that wedge? 30, good. Okay. It's very easy. Now, this is the isosceles triangle, correct? Is the 30 a base angle? Is the 30 a vertex angle? Vertex, okay. So your vertex angle is at 30. How much is left for the base angles? Well, how many degrees are in a triangle? Back up to 30, you're left with? Okay, so you have 150 left for the two base angles. How much is each one of them? Go. So again, it's not difficult. It's simple adding, subtracting stuff from the triangle. Understanding where that 30 degree is placed. That one's placed at the vertex. Okay? It's the vertex angle. All right. Excuse me. All right, going back, we had to figure out the entire segment length of RU. So, you know that the triangle on the right is equilateral because it's got 60s, which means if this is 12, this is 12, and this is 12, isn't it? What's this? 12, okay? What do we do now to figure out this? What kind of triangle is it again? It's a right triangle. What do you always use to find a missing side length in a right triangle? Pythagorean theorem. You always use Pythagorean theorem. Now, in that right triangle, you have a side length of 12 and a side length of 15, and then an unknown side. Which one of those side lengths plays the role of the value of C? 15. Why does it have to be the 15? The biggest one. It's the hypotenuse, okay? The largest angle is always across from the largest side length. In a triangle, if you have a 90-degree angle, can you have any other angles bigger than 90? No, because it'd be over 180. Also, go like this real quick with your hands. You want, as you open your fingers apart, as you pull it apart like this, as the angle at your heel of your hand, as that angle gets larger, what's happening between the fingers? It's getting wider, isn't it? So the bigger the angle is, the longer the side length would be across from it, isn't it? So if this is at 90 degrees, that's a lot larger than it is at 15 degrees. So what happens here is, this is another something we haven't quite learned yet, but there's rules in math in regard to side lengths and angles. The larger the angle, the longer the side. So the biggest angle in any triangle is always across from whatever the longest side length is. Again, can you have any side length bigger, or excuse me, any angle that's bigger than 90 in a triangle? If you already have a 90. No, so this has to be the longest side. So you've got a squared plus 12 squared plus 15 squared. Now, back to just pressing some buttons in the calculator, this is a really, really easy problem to do. You get 225, subtract the 144. Okay? And then you get a squared is 81, which gives you 9. Okay? Remember, Pythagorean theorem isn't something that we've really discussed, but it's something you guys use all the time. But the last thing you would do here is what's 9 plus 12? There you go. Okay. You're just utilizing properties of equilateral, using properties of isosceles to kind of piecemeal your way through a problem. Not a really difficult problem. It just takes time to remember what you're looking at. Right? Terrible-ish? Hope not. Let's see how I have right here. Let me pull this up. So I have a copy of this, so you don't have to keep drawing pictures. there's an A and there's a C side. I'm on the A side here with you. So, as I was saying, oops. Excuse me. Oops. All right. What am I going to do now to find x? What do you have to start doing?
Algebra.
You got to do algebra, correct. Now, when you look at that, you've got 3 angles. You're given one of them, and the other one's got the variable. So that means you have to decide, is 40 the same thing as, is angle E the same thing as angle D? Or is angle E the vertex angle? The vertex angle. Everybody see that that's got to be the vertex angle? Even though it's on its side, it's okay. Where the 2 congruent sides run into each other is always the vertex angle. So, once again, how many degrees are in a triangle? 180. If I back out the 40, how much is left? 140. So if I've got 140 degrees that has to go between 2 angles, what is each one of them? Go. So you have 70 here and 70 here, which means you set this equal to 7. Alright. I know. Now in this case here, it's a 2-step algebra problem. It is not difficult. You add the 18, and you divide it by 11. I know we probably haven't had to say this in a while, but over the course of the next few days, make sure you've got your calculators with you. Okay. Take a second to figure out 13. Might as well do 11 too. Do 11 and 13 real fast. Hey, don't. If you want to run the restroom, it's fine. One second. Okay. So when you set that 11 up, you just have to make a decision on which two sides are the ones that are the same. Obviously, when you have the worksheet in front of you, easiest thing to do is just follow your angle. So the angle looks at the side, that's the same. All right, remember the angle opens up to the sides, so they're the same. So you just have your 9x minus 8 is the 28. Add 8. And then divide by 9. And you get 4. Okay. If I asked you what the perimeter of that would be, what would you do? Remember what that meant? Perimeter? Yeah, you just add up the sides. Yep. I just wondered if you remember. On 13, what do you do with those angles? Set them equal to each other, yeah. And we have to set them equal to each other because they are across from the two sides that are the same. Okay? They're across from the two sides that are the same, which means they have to be equal. So in this case here, you have 7x and 5 is x plus 47. Variables on both sides of the equation, always pick on the little guy. Do that same time if you like. You get x to 7. Okay. Now remember, sometimes it might ask you to solve for x, it might ask you to solve for the angle. It just depends on the problem. It might even ask you to figure out what the angle h is. Okay. So if it asks you to figure out what angle h is, what would you do with that 7? You'd figure out the other two. Okay. So if I did that, what's 7 times 7? 49. Add 5 to it, what do you get? So it'd be 54. 7 and 47 is 54. What's 54 and 54? How many degrees are left to get you to 180? 72. Very good. Those are the little things that you can do. It's not it's not complicated. You just have to look at the big picture as far as how things are being set up. Okay? And that's just how it's going to work itself out. Now, if I got to solve for x and y, it's obviously an isosceles triangle because it only has the 2 tick marks. I can't set those two base angles equal to each other, though, can I? Can I equal them to 98? No. But can I figure out what each of those two angles is? What do you do? Yeah. Yep. So you start by backing out the 98. And you get 82. All right. What do I do with the 82 to figure out the two angles? Yep. Cut it in half. Very good. So that means both of these angles have to be 41, right? And then you would solve them independently. You're just walking yourself through using a couple of the rules to get you through it. Okay. Hopefully it's not too terrible. Other one. So for tonight then, I want you to do on the other side 1 through 3, 10 through 12, and 13, 14. Yeah. So on the 4-7C side, 1 through 3, 10 through 12. Is it 13, 14? Yeah, it's 13 and 14. Oops. There's 8 of them, ladies and gentlemen. Okay. Now, one of the things I want you to look at on 10 through 12, it says find the perimeter, which means you got to find x and y, and then just substitute back in to figure out the side lengths. Okay. So don't forget about that. It's really easy. All right. Honestly, you got 15 minutes. I don't see why you can't have this done before you walk out the door. It's really fast. All right, listen. All right.